In this video, we're going to be graphing a quadratic function, or the parent function of the quadratic function, using a table. Then we're going to determine how a graph opens up or down, and then what else the vertex might give us. Let's start with graphing their parent function. So here we have y equals x squared, and so we're going to make a table. For our x values, we're going to be using -2, -1, 0, 1, and 2. To find these values, we're going to plug each of those into our parent function, into the x's place. So we'll be using -2 squared, which means -2 times -2, which gives us a value of 4. If I plug in -1, I'll get a 1 because -1 times -1 is 1. So I can finish plugging in the rest of my values to get 0, 1, and 4. And you might notice that we have some repeating numbers here. It's still a function because even though our y's repeat, the x's don't. And so it's still a function. And so we're going to go ahead and we're going to graph these points now. So we're going to graph -2, 4, -1, 0, 0, 0, 1, 1, and 2, 4. To finish our graph, we're going to go ahead and make a nice little smooth curved line there. And so this is what our parent function looks like. It has a domain. So when we talk about domains, what are the x's allowed to be? So notice here that our x's kind of keep going and going and going in the positive direction, and the same with the negative direction, which tells us that our domain is going to be all real numbers. X can be any number it wants to be. Our range, on the other hand, meaning what is the y allowed to be, is confined. The lowest value we have occurs at 0, and nothing below that happens. So that tells us that our range must be greater than or equal to 0. This lowest point on our graph is what we call the vertex. That occurs at either the lowest point on the graph or the highest point on our graph. And again, that's called our vertex. So then the question can be asked, well, how can you tell if the graph is going to open up or open down? There's a way to do that without necessarily needing to graph the function. So if you look at your a value, so recall that the quadratic formula looks like y equals ax squared plus bx plus c. That's what a quadratic function looks like. And so we can gauge it all off of our a value here. So we can say that if that a value is a positive value, then it will open up like we see here. Notice that our x squared was a positive x squared. But if that a value is negative, then our graph is going to reflect across the x-axis, and it is going to open down. So instead of looking like a U, it's going to look like an N. So open down. And again, that's a reflection across the x-axis. So we don't necessarily have to graph a function to know if it's going to open up or down. Let's practice that a little bit. So here we have 3 examples, and we're going to be determining if the graph opens up or down, and then explaining why. So in our first example, we have y equals x squared, which is what we just graphed. So here, if we look at our a value, we see that that is a positive 1, because it's a 1x squared, which tells us that our graph is going to open up because our a is positive. If we look at letter B, we have y equals -x squared plus 4x minus 8. Here, our a value is negative. So because that's negative, our graph is going to open down. And that is because our a is a negative value. I want you to try letter C on your own. So push pause, and then when you're done, push play, and let's see if you are correct. So for letter C, we have y equals 3x squared minus 2x minus 4. Here we see that our a value is a positive 3. So because our a value is a positive 3, that means that our graph is going to open up because a is a positive number. Recall that our lowest or our highest point on our graph is our vertex. So there's something else that our vertexes give us, some other information. So here we see 2 examples, one with the graph opening up and one with the graph opening down. Notice that our vertex for the graph opening up is at the lowest point, and when our graph opens down, the point or our vertex is at the highest point. So when the graph opens up, our vertex is also known as the minimum value. When our graph opens down, our vertex is known as the maximum value. So our vertex can give us a lot of information. And our A value does that as well, because our A value will tell us if a graph opens up or down, and if our vertex is a minimum or a maximum. And we can get that information without necessarily having to graph our functions.